All right, so let's finish this up here. Let's see, where were we? So we were about to integrate this with respect to x. So we would have to, x to the fourth is easy to integrate, but over here I would need some u substitution. So u would be equal to x squared plus 1. All right, so then my du would be 2x dx. So that means that I would be able to replace x and dx with 1/2 du. All right, so that front part there, let me take that over to the side. So I'm basically doing the integral. I'm replacing the x and the dx with 1/2 du, so I have a 1/2 and then du. So this x is getting replaced, and the dx. We're just kind of do this in two pieces. And I basically have u to the 3/2. So u to the 3/2. All right, so integral of u to the 3/2 would be u to the 5/2 divided by 5/2, so times 2/5. So this 1/2 would still be there. So basically I would have 1/5 u to the 5/2. So since u is x squared plus 1, I'd have that to the 5/2. Okay, so that's the integral of this piece right here. Okay, so let's go ahead and finish the whole thing. All right, so the integral of that piece. So I still have a 1/3 out front for everyone. The integral of that first nasty part was 1/5 x squared plus 1 to the 5/2. Okay, and in the back, I have the integral of x to the 4th would be x to the 5/5. All right, evaluate this from 0 to 1. Now, to make it easier on myself, do you notice that both the things inside those parentheses, inside the bracket there, it has a 5 on the bottom. So I'm going to pull out a 1/5 and make this 1/15. And then I just have x squared plus 1 to the 5/2 minus x to the 5th. Evaluate this from 0 to 1. Okie doke. Yep, looking good. All right, so leave that 1/15 out there. Let's make a bracket here, so plug in a 1. So when I plug in 1 to x squared plus 1, I get 2. So I have 2 to the 5/2 minus when I plug in 1 into x to the 5th, I get 1. So that's the front part. Minus when I plug in 0. Well, when I plug in 0 to x squared plus 1, I get 1. So I have 1 to the 5/2. So minus 1. And then when I plug in 1 into x to the 5th, I plug in 0 to x to the 5th, I get 0. Okay. So I basically have 2 to the 5/2 minus 2. So 2 to the 5/2 minus 2, which is a nasty answer, and then I have a 1/15 out front. So if you really want to, you could put that in your calculator. It does come out to 0.244, but again, just leave it like it was. It's fine. Okie doke. So let's go on. We did that one. Let's get these other two done. So looking at this problem here. Find the volume of the solid that's bounded in this region from -1 to 1 and 0 to pi. So I'll be setting up my double integral. Now, looking at this problem, the way it's presented, that z is mixed in. So you do want to solve this for z. Right? So you get z equals the e to the x sine y plus 1. Now looking at that, the e to the x and the sine y are multiplied, but they're not really like, I can kind of still have them separate in my mind. It's not like I have sine of xy or e to the xy. They're not mixed together. So I can treat them as kind of separate. So I really don't care if I do x or y first. I can do dx or dy. It doesn't matter. All right, so I'm going to do dy first, and let's get rid of that sine stuff. All right, so also because we don't do dy first a lot, so let's just practice that. So remember, this is x and this is y. So I have 0 to pi and -1 to 1. My function is e to the x sine y plus 1. I'm doing y first and then x. All right, so when I do the integral of this part with respect to y, integral of sine is negative cosine. So I'm going to get a negative e to the x cosine y. The e to the x was just sitting there. And then the derivative of this guy over here with respect to y would just be plus y. I have to evaluate this from 0 to pi. Okay, so, and I still have my other integral to do, but I'm going to evaluate this first. So pi. So pi on the unit circle is negative 1 and 0. And I'm going to be plugging in 0 also. That's 1 and 0. All right, so the cosine of pi. So I get negative e to the x. Remember, I'm plugging in, these are my y values that I'm using up here. All right, so I'm plugging in pi. Cosine of pi is negative 1, so I'm getting a negative 1 from that. Plus, when I plug in pi, I get pi there. So that's the first part. Minus when I plug in 0. So I still have negative e to the x. Plug in 0 for cosine, I get 1. All right, plus when I plug in 0 here, I get 0. All right, so let's clean that up. So this turns into e to the x plus pi. And in the back, I get plus another e to the x. So I'm just going to say 2 e to the x. Okay. All right, so now we got to finish our integral. So let me bring that over here. That was the inside integral. So I still have to do the integral from negative 1 to 1 of this problem. 2 e to the x plus pi dx. All right, integral of 2 e to the x would be 2 e to the x. Integral of pi is a constant, so it gains an x. And evaluate this from negative 1 to 1. So plug in 1, I'll get 2e plus pi. Plug in negative 1, I'll get 2e to the negative 1 minus pi. All right, so I have 2e, let's see, minus 2e to the negative 1, or 2 over e, and then the pi's become plus 2 pi. And there is my answer. I guess this was presented as a volume, so I could say units cubed. Okay, alrighty, so last one. So this is just a rule that you have if you want to make things a little bit simpler. And we could have kind of used this on the last problem because the problems were not really like the x and the y weren't mixed together. So this little rule up here says if you have like basically two separate functions, one of x and one of y, and they're multiplied, you could just break it into two integrals that are multiplied together. So this is x and this is y. But they're both the same. So this problem right here, I could break this if I wanted into integral of sine x dx from 0 to pi over 2 times the integral of cosine y from 0 to pi over 2 and dy. So if nothing is mixed together, and they're totally separable, you are allowed to do this. And so this will help you sometimes, and later on in some harder problems it'll help you too. When we get to polar functions or polar coordinates and things like that, and spherical coordinates. All right, so integral sine is negative cosine. Evaluate this from 0 to pi over 2 times, let's see, integral of cosine is sine from 0 to pi over 2. Okay, so cosine, let's see. Cosine at pi over 2, the coordinate is 0, 1, so the cosine is 0. Minus, when I do the cosine of 0 is 1, but there's also a negative in front of there, so it'll be plus 1, times, over here, sine at pi over 2 is 1, minus the sine of 0 is 0. So, this is the second most exciting answer, and the answer is 1. All right, so 0 is the least exciting, and this is the, I guess, the second least exciting, I would say. All right, so for your homework tonight, why don't you do 3, 5, and this is after break. I had that for like last year or something. 3, 5, and 7. Try those 3. All right, and I'll see you in class. Bye-bye.